Hey, Coffee Compiler Club here today to talk about compilers and language runtimes and whether or not I need to get a full spectrum movie, film industry theater light for my wife, and any other thing that comes across. We're all getting, oh, I see. We're all getting film. We'll show up on YouTube in a while. We've been doing sound checks with Levo. So for people who didn't like Levo's sound last time, which was pretty janky, Levo's having issues, but his sound is much better today, but he may disconnect. That was the warning there. All right, no set agenda. Anyone want to start? And if not, I'll throw down some short update on XTC coding things. And Theodore, you wanted to do Elixir. You still up for that, or are you going to like fall over on us?
I'm pass. Exam.
Well, I can give a very brief update.
Yeah, fine.
Yeah, so I've been working on, well, I was pretty happy with, like, in the first month working on this project, basically got all the ingestion and the kind of basics of the graph and the type stuff all working, function ingestion. And I had a lot of tests, but I wasn't very confident about correctness. So I spent like a couple of weeks and just did loads of like built up testing and
that's very
correctness
nice
stuff.
when you get to do
What's
that.
that?
Yeah, it's very nice when you get to do that. Yes.
Yeah, it's like kind of have to force myself to, because while I'm doing it, I feel like I'm not making progress, but
Right.
or actually I feel like I'm regressing because
You
I
find all the
find
shit that you
errors
thought
and
was
I'm like,
working.
this was working, kind of.
Yeah.
And now I know it's not working, and then eventually I get it. Now I'm sort of back to everything that I've been able to test is working, and now I have a lot more confidence. So the one thing that was super core that I hadn't built was loop ingestion. So I did that, and then I got my widening stuff working, and yeah, I'm pretty happy. It's like things are working. I'm finally, well, I mean, it's not finally, I'm pretty happy with the pace. I'm just about to start with like the platform specific stuff, like the untether specific stuff.
This is still a PE array thing, right?
PE array stuff and like all the intrinsic functionality and stuff so that the basically the reason the thing exists.
Yes. Yes. Okay, fine.
And then and then the next step I'm doing the evaluator. And then I want to try and do something something kind of like the code generator that they did in Simple, but I'm gonna try
Hello, we have a code generator. It's a
like they're the fuzzer, right?
the fuzzer. Oh, yes. Oh
I don't know.
God.
I mean, it seemed like that
Sure.
was providing quite a bit of value for you guys, right? Because you're
Yeah.
finding issues pretty early.
Yes. It produces code that no human would ever write, but ought to work.
Yeah.
Yeah, it finds all kind of stupid shit that you'll hit the hard way eventually anyhow. And
Yeah.
C2 went crazy popular, and the kinds of things that the last year of fixing C2 bugs that I was there fixing were things that a fuzzer would have caught, but it required a billion people to be writing screwy code to get those to show up in a way that you could debug them.
Yeah.
Fuzzer is helpful.
Yeah. I think if I get a fuzzer going and it's too much of a pain, like it's producing stuff that's just too obscure and I don't care, then I might not stop using it. But I think I'm going to at least try. But I want to try using this sort of generative testing approach, so that I can actually have a fuzzer that does shrinking and stuff like that. So we'll see.
The shrinking is crucial because the first crashes are ludicrously huge.
Yeah.
And I think the set of bugs that Simple's pretty simple too, but the set of bugs the fuzzer can find seems in my head to be limited. It found them, having found them, new fresh bugs are rare and coming, maybe without either getting Simple to be more complicated or get the fuzzer to be more targeting.
Yeah.
As it stands now, there's only so many. I've made a dead test to a dead infinite loop to a dead this, that causes me to say suddenly, oh, I've got a dead thing going on. Whatever, all right, and you got all those, and it's done, and they're a pain in the neck, and you have to have all these cutouts in the parser and this and that. Okay, but okay, it's done now.
Yeah, exactly.
Fine.
Yeah, and I think it's good. There's something to be said for doing it while you sort of have that very much loaded in your head.
Oh, yes, totally, absolutely.
So you just sort of tackle it all at once and get it done, and
Right.
then you can forget it all safely.
All it ever existed.
Yeah.
Yeah, here, let me see if I have. I probably can find a post cleanup version of a simple of a fuzzer output. I don't know if I have a pre cleanup one. They're pretty brutal and they get thrown away pretty quick after you do, but they're fun to
How do you
look
guys
at
do the cleanup
once.
on the fuzzer stuff? Is it manual or is it automated?
Oh, the fuzzer. I'm sorry, say it again. Which piece is?
How do you get the cleanup from the fuzzer? Is it?
Oh, that's automated.
It's
So the
automated.
fuzzer reports, hey, here is a here's a thing. And then he grinds for a minute, and then here's a reduced thing. I threw in the Google Docs, I'll go share a reduced test case, the last crashing reduced test case that we got out of the fuzzer. There you go. While false, yada yada, layers and layers, int, while false, while negative, while this, while return zero break, negative break. What the hell, right? How did this crash? Okay, fine.
Before we implemented the Java-aware reducer, we somewhat successfully used creduce. And I heard people do the same for other languages.
Use what?
Creduce. It's like reducer for C programs.
Oh, okay, yeah.
I heard, that's the one. And I heard people use it even for R programs. Like, yeah, sometimes it may not know useful reductions for your language. It may create incorrect programs, but you don't care. If it found something that is smaller than original reproducer, great.
Oh yeah. Oh no, the original from this was several hundred lines long. Also, all variable names were between 10 and 100 characters long. Like that part of the fuzzer, it's not crashing anything, and we should just use short variable names out of the fuzzer. But the nested if while dead tests are whatever, and eventually it found a path where somebody didn't get put on the work list that should have been put on the work list. So it was a minor bug in that it found a missing peephole that probably would have been hit anyhow because of later things you do on the peepholes. But the first go stopped somewhere in the middle and said, no, at this very point in time, if the work list were to pull this node off, it would make progress, but it's not on the work list. So,
by the way, I'm quite proud of something that I did, and we'll see if it actually comes out to work, but so far it is. All of my work list adding stuff is fully automated now. So when I run patterns, it tracks every node that I'm looking at through the pattern as I'm running the matcher, and then it all gets onto the work list. And then when I'm making changes, whenever I unlock a node, I capture that as a list. So every time as I'm doing the peephole, every time a node is unlocked, that gets added to a list. And then after the peephole is done, because I do it sort of, I have this sort of outer loop, which is, well, it's the work list, right? So you have that as well. So after I'm done and I'm ready to go to the work list, I capture everything that I've unlocked and I add those and their neighbors to the work list. And then I can resume. So then I don't need to like explicitly capture something as dependencies or anything. It's like anything that's been unlocked has potential neighbor impacts.
What's the pattern for locking and unlocking and relocking? You have to go relock them for the next peephole.
Yeah, so I do that as well. So it's actually nice because I capture everything that I've unlocked at the end of the peephole. I just call relock all.
Right. All right, and then now all your node accessors have to stop and do the lock thing. I'm asking because this sounds, I've thought about how to do this on and off. I never settled on something, but I'm very interested.
Yeah, so yeah, so the main thing is that, well, one difference that I have in my graph representation is that every node actually has a link back to a graph object.
Oh, I
And
see.
so anything that's global, instead of doing it actually global, I do it in the graph. But
Okay.
it could be global, it's the same. So then in the graph, I have this list of things that are unlocked, and it just adds, and whenever I unlock something, I just add to it.
When you use an accessor, I'm jumping from this node to that node via input number 1. That input
doesn't
number,
unlock.
I'm
It's
sorry.
only when I make a change, and then my unlock is the same as your edge unlock or E unlock.
Okay, that's only on changes, but the
Exactly.
peepholes.
Those are separate things.
Yeah, okay.
So the peepholes, I have the pattern engine, and so as I produce patterns to match against, I pull every node that's in the pattern out, and I add them to a list of things that I've looked at.
That's what I was trying to sort out. Not the change list, it's what you looked at during the pattern inspection. Then the pattern fails because but you don't match the pattern, but you looked at a bunch on the way to failure.
Yeah, and so then every node that goes through the peep list, I capture a bunch of things in this, like what I've looked at. But if the pattern doesn't match anything, if I don't make any changes, I just throw that list away. So then when I do a next node and I start doing pattern matches, and then maybe I look at some node, I may look at multiple different patterns for that node before I actually find something that matches. But I'm building up this list of things that I've looked at. And then the pattern matches, I make some graph change. After that graph change, then I can take this list of things that I looked at and I add it to my work list, right? I think I add the neighbors of everything that I looked at as well. I can't remember.
Let me throw out a concrete example here when I'm trying to figure out how it works. I have a pattern that if I see A, B, and C, I'm going to replace A with D. So I start with an A, and I know I have an ABC pattern I want. I look at the B, it's there. I look for the C, it's not. So I've looked at A, I've looked at B, and A is always sees the base, I don't care. I looked at B, I failed to find a C. So the pattern didn't fire. Later in life,
A and B would be on the list of things I looked at.
Okay. Later in life, whatever was in front of B flips to a C.
Yeah.
Now I want to go back to A, not to B, and ask the ABC pattern again.
Yeah.
How does that work? So I look at A, I look at B, I don't find a C. I have an A, B on my list. I threw them on the work list, I guess, maybe, I don't know. Nothing changes. A and B come off the work list. Nothing changes. I toss them away. I'm back pulling some random dude off the work list. He changes an X to a C in front of a B. I need to go back to A and say A is a B, has a C. Oh, pattern matches.
Yeah, I'm not permanently capturing a relationship saying that every time, well, C wasn't there, so it wasn't matched against anyway.
It wasn't. That's correct. A and B were matched against. And I'm hoping that, well, for me, I do the A, the B, I get to the X, the wrong thing. And I do throw the dependency, now it's manual, it's not automated. I throw the dependency on A onto the X guy. Later, when X swaps, I go back to A and try again, see if I can find an ABC. I don't necessarily, it has nothing to do with the C. I don't know if a C will ever appear. I just throw X has a connection back to A.
Yeah. Yeah. So the C would, if suddenly this new C appears, then presumably it has some connection. And when it adds, like the neighbors of that are going to get.
Well, the neighbors of C would be B, but I need to catch A. The pattern starts at A. This is like a stupid Google Docs thing again here.
Yeah.
It's not any big deal, but we're all talking here. So somewhere in the universe, the pattern I'm looking for is A arrow, B arrow, C, and then I'm going to replace. Oh, look at this funny arrow Google does for me. Replace this with a single ABC choice. And then the graph is arrow B, arrow X. And I walk the graph. Oops, visiting, A, B, X. No pattern match. No pattern match. No C in graph. Sometime later, I get some pattern on X, and I replace it with a C, and now the graph becomes, right? Oh, here, and work list. So B, so the work list has a B, we do curlies. Now the graph is A arrow, B arrow, C, and the work list has a B. So I'm missing the A to go find the base of the pattern and go walk it again. And what I do now is manually I add the dependency from X to A as part of the ABX pattern. As soon as the pattern fails, I take the failing guy and add the base of the pattern to the failing guy's dependency.
Right. I guess, yeah, so I'm not capturing this.
Okay.
But I guess you could do something like that if you said that.
Well, it's the same as your unlock. I do A, I do B. It's good, so I don't need to put them on the list. I do X, I fail, but I've been touching as I go. I take the failed guy and say, add the base.
Well, somehow X,
as I'm doing,
oh, go ahead.
As I'm doing this, I'd be B and X would be added to the work list.
Because you walk from A to B to X, even though there's no changes?
Only if something changed with A.
Okay, so you walk A, B, X, it's unrelated, it failed. Later in the same work on A, you change A.
Yeah.
Yeah,
now
I do that. I mean, if I change a node A, I just put A back on the work list. But I don't put B and X on the work list. But if I've changed A, I'm sorry, I put the neighbors of A on the work list automatically if I change A.
Yeah, so I put the neighbors automatically as well, but then I also capture those. So there's some overlap and I just deduplicate it.
I see.
But I would add X, and that seems to be, maybe I'm misunderstanding, but that seems to be what you do when you call .dep.
When I add deps, I add
Like
deps says on.
You have that thing that you do while you're peeping where you have like, I thought it was just dep, but maybe it's add dep. But
there's an add deps and then there's move deps to work list.
Okay, but as you're doing the peepholes, sometimes you've got this little like call that doesn't really change anything about the peephole, but it's just like saying, oh, this node I need to remember.
Yeah, that's the, so, okay, so the minimalistic thing that I would love to do is say, when I walk from A to B to X, X is the fail point, add the dependency from X back to A. Sometimes to make the code easier, I'll add junk dependencies as I go in case I were to fail, but I need to do some more checks there. And I don't have all extra code to be minimal adding dependencies. So I add a few extra dependencies. So sometimes it's the case I go A to B, and I haven't looked at all the options out of B, but B has several patterns you might like. So I go ahead and add the dep on B back to A. Then I look at the X, I fail, I add the dep for X to A, definitely. I pick up the one for B because A, B, something has 5 other patterns and I don't want to like pick and choose too carefully there.
Yeah.
So it's not minimal for the patterns I'm looking at, but it was easy because of the flow. I have these flow coding styles. So it just says if with add deps thrown in the middle.
Well, maybe it would make sense for if you have a failing pattern like this, that some relationship in the graph from X to A is actually added like permanently. So you have like a sort of
that's the add depths.
Does that actually add something to X going forward?
It adds a dependency, but not a graph edge. The dependency is just a list of other nodes who I want to revisit if X were to change.
Right. Yeah, you know what? I think maybe I've done this part a little bit wrong. So this is different from the unlock thing I was talking about.
Right. Yeah.
Because right now I'm just adding them to the work list, but maybe what I should probably be doing is adding something to X saying, hey, when you change, notify, like throw A on the work.
If you were to walk A, B, X and fail, but throw X onto the work list because you attempted and it didn't work, and having thrown it on the work list, X now discovers that he can become a C, you're mostly further along. So for doing this, I have a test, I have a giant ass assert I run.
Yeah, but there's nothing really about doing the ABX pattern that indicates that X might change. Like either X should be on the work list or not. Like now I'm sort of.
It's not that X should be on the work list, is if X were to change, which it has to go on the work list to change. If X were to change, then I want to go revisit A.
Yeah. Yeah. Okay. I need to change that actually.
Okay.
So, but yeah. So yeah. So the thing that I did that I thought was kind of nice was adding like when I unlock nodes to actually capture that as well. And then that way, because what I had to do previously was I would do a peephole and then I'd say, okay, here's the changes that I'm making in this peephole, but I would have to sort of notify the peephole engine that here are some things that you also need to add to the work list because I know this peephole is like I added an edge to that thing or something.
Right.
But now because I capture that sort of in the background whenever I unlock something, then it all gets picked up by the peephole engine in the background. And I just don't need to remember, because it was always a source of bugs in my first compiler that I would forget to tell.
Yeah.
You know,
I have the nasty assert I'm going to show in their Emacs here about how I fix that class of bugs. And sometimes I do just what you said. I call it add flow or add to work. And then sometimes I do the dependency because I'm waiting on a change.
Yeah.
Let me stop. Let me share. Why did you change where your share came from? Thank you. Here's an Emacs share. The font's going to be too small. Something. Okay. Yeah. Right. Fine. So, and then my window went off its size because Emacs and Zoom aren't terribly copacetic. Okay, yeah, right. So somewhere in the world, I have this iterate function. It says while work list, peephole, if change, blah, 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 move depths. Down here, assert progress on list. This is a full n squared assert, and I can move them out a layer periodically. I do to confirm things, and it just says start from a node, the stop node, walk all nodes, run the peepholes. If the peepholes did a change, put a breakpoint on break here for bug, you found a guy who should be on the work list and is not. So it says if work, return null. That means if he's on the work list, I'm not going to try.
Yeah, I do that too. I actually.
Okay, well, this should catch your things.
It catches it as an error, but what I want it to do is that it automatically catches things and puts them on the work list, so I don't actually have those errors.
Right, and I have to manually add my depths. Yeah, I want that too. Right, I'm manually adding depths where this catches where to manually add the depth.
Yeah, so I have a version of the runner where I pass a check argument and I set it to true, and then it does that same assert. Yeah. So I can do it either on or off.
Right. Yeah, manually moving mine, and it's on some of the time right now, and
Yeah.
not on all the time.
And you know, I moved from, in my previous compiler, I had an immutable graph that I would then switch it to mutable mode. It could be toggled, and I would make some changes in the peephole, and then I would sort of switch it back to immutable, and then switch it. So I'd switch back and forth between immutable and immutable, and I'd get these snapshots along the way. So this time I decided, you know, I'm just going to create a pure mutable graph, but then snapshot it whenever I want it. And so, and then I just create a linked list going back in time of snapshots. So my current graph is always the same, which simplifies things. And then I'm constant, like anytime I want, I can call snapshot. And then the graph object that's tied to every node has a member called previous, prev, and it just inserts into the linked list there. So it makes a snapshot of the current one, moves the previous into that one, puts this one into the previous, and then I've got like the linked list just grows back in time.
And you're using this to debug some kind of bugs. Like, is this more or less productive? Like, so, I have a different strategy for doing. Boy, the sound is cutting out whenever we both talk. So you talk.
Okay, so it's super fast to snapshot the graph, and you know, all I do is clone every node, and then and another thing that I do is I do a very quick hash of the graph. And the hash of the graph is just a hash of every node ID. So I don't hash all the node hashes. I hash every node ID. And I think that's all, actually. And then I store it in a map of all the known hashes. And then every time I snapshot the graph, I check whether I've gone back to a state which I've already been at.
Are you looking for self cycles?
Yes.
Okay, fine.
And
I don't have any trouble with self cycles. They happen.
Yeah, well, but when they happen, they're annoying also because it becomes an infinite loop and it just runs forever.
Right. And so you break it in and you see these three guys are spinning around each other. It's infinite, so you can just break a point any time. And it's always the same 3, 4, 5, however. Some of the peepholes are like churning on each other.
Yeah. So mine, the theory is that if I get this, it'll
catch you quicker.
Crash immediately.
Yeah.
And as I'm working, I add the most recent node to a global. So then I have these tools which I can like visualize the graph or like look at it. And so I can just call these functions, and they by default refer to this global node. So I can just say view the graph, and it views the one that it just crashed on, or I can view the graph history and all this stuff. So it's actually quite
okay.
I feel like I'm making things fairly
right. I mean, I'm using the peephole counts to binary search, but I can't at one point in time stop and view multiple different versions of a graph.
Yeah.
Okay. Yeah. Yeah.
Yeah. So I have this whole thing where I visualize like all the versions as they go, and I made it because the snapshots are really fast and the whole thing is like nice and fast, especially compared to the old compiler. I snapshot the graph now every time I create a node. So it's like the visualization is like very detailed. But when I have some process that doesn't work, it's very easy to just say, okay, give me a subset of snapshots from 50 to 60, visualize them, and I can see what it did. And often I was like, oh, wait, why am I doing that?
So when you visualize, you're talking about it's a, graph viz dots, like I'm doing in simple for demos of what graphs look like.
Exactly. Yeah. So
and how does that work when you
it does a bunch of visualizes side by side. So this works
1,000
because
nodes.
I'm mostly working with small graphs. Once they
Right.
get bigger, it'll be too annoying.
Yeah. I did it in C2 on and off, and it was always great on these little nodes for intuition, for tutorials. And it was no help when you had 10,000 nodes in a graph. It's just soup. And, you know, it couldn't.
But then one thing that I did in the previous one, I haven't gotten around to yet because I haven't gotten big enough graphs, is that I would say visualize and I would just provide a set of node IDs that I want to look at and only look at those.
Yeah, you know, that could be really useful. It's always the case that I'm trying to diagnose a graph shape, and I made a peephole and I got a new graph shape, and they're both kind of marginally in the middle of some other greater transform kind of graph shape things, and you know, that's where your bugs are fine. And I manually draw them, whatever. I like the notion of being able to pop up, like I'm in the debugger and it stopped, pop up a graph viz, go backwards some set of peepholes and pop up another graph viz, and limit them to just this particular area. Maybe I just have a list of node IDs I can keep expanding as I want to grow my area, and then tell the graph is just trim this.
Yeah. Yeah, in the last one I had a bunch of tools around that. Like I would say, show me these nodes plus their neighbors to X distance. Neighbors to very much distance tended to be a lot of nodes fairly quickly, but neighbors to one was usually good.
Yeah.
And then yeah, I'd select them by type and stuff. Yeah, I had a few tools and I usually found something that was pretty useful.
Okay. Well, maybe I'll think more about extending the tool chain there. So I do have the print to neighbors, and beyond 3, it's kind of like all. It's not, but it's big.
Yeah, exactly.
Big, fast.
But I think also if you do to neighbors, but then you exclude certain node types. So for instance, by default, I don't show struct nodes in my visualization. I have to put a flag to turn them on because they add a lot of noise.
Okay.
And
interesting. Yeah, it's a different.
Yeah, I think I would also probably not show the root node. And also one thing I do in my visualizations is constants.
Yeah.
I do not have, I have every time a constant is referred to, I have it visualized as a unique node, because otherwise they bunch up the graph like in an unhelpful way.
I'm not doing that, but that's probably a thing that should be done. I'm aware of that one. Yeah.
Yeah.
Interesting. Okay.
Anyway, I'm pretty happy, making good progress, but
there you go. Okay. Yeah, the graph viz tools are like a lot of work, but they're a lot of, you know, if you spend the time on them, they can pay back.
You know, I think you guys made your graph viz way fancier than mine. Like I use this D2 thing. I've got like a 50 line of code thing, and I haven't touched it since I actually just copy and pasted it from my last project, changed a few lines, and it's unchanged.
Right. Yeah, it was a tutorial, so we spent a little money, you know, time on making it prettier.
Yeah.
Same as the ASCII print. The ASCII print, I can dump 1,000 nodes and then put them in an Emacs buffer and search and sort them, not sort, but you know, search around. And the print does basic block layout things and stuff like that. So it's not a gruesome bad.
Yeah, you know, I was thinking about so I haven't even done the ASCII print version yet. Last time I had this whole table thing, and I didn't really like it, so I didn't want to do it the same way. I haven't done anything yet. I was actually thinking that maybe I should just generate HTML, and then I can actually link between IDs. That way I can click around.
So a very common debug pattern for me, and I don't know how I get in my workflow, is I'm in IntelliJ, it's hit some assert, blah, stopped. I say no dump depth 3, 5, 10, whatever, 99 if I want it all. And then I just Control-C, Alt-Tab to Emacs, Control-B, a buffer up, yank it in, and now I have a searchable, sortable. I can screw around, I can add notes and annotations.
Yeah.
It's a very quick pattern. IntelliJ does a few stupid things. I could make it quicker.
I was also thinking, so it's really quite easy these days to generate Excel files.
Excel?
And I was thinking, so I was thinking that maybe I should just dump to Excel and then, you know, open it up in Excel, and then I can really mess around with stuff, filter and sort and whatever. So this is something I was thinking about.
In my head, it's not a two-dimensional, it's a one-dimensional structure. It's a list, or it's a full graph because I need a graph, but it's not a 2D thing, which is what excels at.
Well, it is though, because you have like, the operator fields are,
I get one long line and it's
stuff.
got operator fields, inputs and outputs, types, this, that. It's a little bit of information, and it's padded out so they line up neatly in a 2D column.
Yeah,
but it's not.
On the topic of using like existing tools in order to somehow visualize the IR, I haven't done this, but I heard I've read people do this for LLVM. So with LLVM, there is a serialized textual format, and I've read people use Git, and they just commit every optimization is a separate commit. You have textual file with your IR, and after that you can do diffs. You can like navigate through them.
A list like the peepholes that were done, or something.
Well, yeah, you dump the IR in textual form after every transformation you've done.
I see.
And then every transformation you just commit it into a like Git repository you created just for this compilation. And then you can do diffs between like every commit now have the name of your transformation. You can look diffs between neighboring commits. You can look diffs between like range of commits, etc.
I don't know. I certainly do ASCII prints of IR before and after kind of transforms, but usually not very many when I'm hunting down a bug. I've crashed here. I roll my count back on transforms. I do a few, and I print. Half my time is the printer isn't smart enough, so I spent half the time sorting the print out so it looks nicer. And then the diff becomes obvious, and I say, "Oh, this is the fuck up," and I'm not fine.
I guess it would work well if your textual representation is easily comparable by diff. Can you actually spot the semantic difference if you look at the diff?
When I was doing C2 and I had very large graphs, I would routinely do diffs. There is an issue where node numbering gets off. Like you think you found the bug fix. You change something. When you rerun the graph, the node numberings all change, so the IRs no longer diff freely. Within the same pass of the compiler, and you have a dump, a transform, and a dump, and transform and a dump, these diff reasonably well. When you fix something, you have a dump and you're broken, so you make a change and you rerun from scratch, the new one has all node numbers different, and it does not diff well. And that was the thing I would love to fix. And
I dealt with this somewhat in my last one, and it worked moderately well. But by the way, Levo actually was raising his hand.
Yeah, Levo raised his hand, and I was gonna look for
I just want to ask why Git in specific, because you could do diffs without it, and I was wondering, is he doing a bisect?
Do you mean about that idea of using Git repository to?
Yeah, Git. Why?
Yeah.
I just have a pile of them and different.
I don't know. I didn't use it myself. But the idea was, it's easy to diff, and maybe bisect actually. Yeah, that's the automation you can get. You have some kind of script on it, and you can do bisect and find where that thing happened.
The reason to use Git was some kind of automation. The obvious one is bisect.
It's got a lot of tooling around it, so there's like nice diff tools and stuff. I could sort of see it, but
well, the diff tools came first, and they're all available without Git. But fine.
Yeah, but I mean, there's like some pretty good integration, and anyway, you can do it without it, sure.
Yeah, and as for that problem of when you made a fix and you need to restart everything from the beginning, so for us with LLVM, because we have serializable representation which we can round trip to, when I have a fix, I just take the IR right before the transformation or right before the pass that is problematic, and that's the thing I'm working with. So I don't need.
Oh, you have a bijection on your IR printing.
Yeah. I can, and that's a big one.
That's a big one. That's interesting.
Two big things. First, we can extract a compilation from VM run, so we can replay it outside of the VM.
Right.
And yeah, most of the time, I'm not running the whole JVM. I'm not waiting for it to warm up and like recreate the same compilation. I have a replay and I'm working with a replay. And then within the replay, I can, like, once I isolated the problematic transformation, I have the IR before, and I just, yeah, work with this IR.
I like the notion of starting with a bijection. You know, this whole thing just brings up a giant ass jig issue. I call it jig. Tooling, customized tooling to hold your work piece in place while you make fine-grained manipulations. You dump the IR after the crash, you dump the IR sometime before the crash. Now you come back into a jig that says, take this IR and replay myself, right? I mean, you act as if I'm here and do these transforms that I listed because they're just peepholes. I could number them all and run them one after another. And then suddenly realize which one blew up somewhere. But restart in the middle is like in the land of simple, most of the stuff's too simple and it doesn't really help. In the land of AA, I'm on and off wondering. In C2, this would have been a giant help. There's a scale thing that's helping here.
Yeah. And we have a fair amount of automation on the QA side where we have tools that, for example, if there was a crash in compiler, we can dump the IR right before the problematic pass. And this is something our QA does. Like, we don't need to do this. And after that, they can run automatic reduction. And quite often, they would reduce things to the point where it is reproducible in LLVM upstream, and they would file it to upstream bug tracker, and someone will take care of it. So literally, we have like a number of bugs where they just have the internal bug. They say, well, we also filed it upstream, and a couple of days later, well, it's fixed.
Okay, nice. That's a wholly different workflow.
Yeah.
I didn't have any kind of access to that. We did have flags that eventually got QA to go work with. That I started out myself, which was I had a binary search flag on C2, a set of flags with a set of shell scripts that effectively did a binary search on problematic things. And after a while, I got it sort of more official into the QA.
Yeah, it took some time to set up these processes, but now it's so pleasant when you if you have a bug that you need to work on and it's not fixed upstream. Yeah, you would have a small IR reproducer. You'll have this specific pass fails on this specific IR. If you want Java program, here's an automatically reduced small Java program that it crashes on.
Makes sense.
So one thing I did, which is sort of like not as far as going with a bijection, but it was quite useful for me for having long-lived graph representations that could survive relatively trivial node numbering changes without the representation changing. What I would do is I'd go through all the nodes and I would replace the node IDs with a string, which was like the node type and then a number. So it'd be like every node type would be numbered from 0. But before I do that, I would sort all the nodes. So I would sort them by like quite a few things. So I'd sort them by node type and then by, I think, their value or something like that, so that I could get a consistent ordering, so that when I, did like, add node 1, add node 2 to add node 3, they would always come out in the same order. And so they'd be numbered the same, even if their IDs were changing. And then in the relationship, so then I might have, a compare node, which uses an add node, and that compare node's def, instead of being some node ID, would be add node 0. And so then I'd have compare node 0, input is add node 0, and its value is this, and I'd have like enough information that I could tell if something substantial changed. But I had this very consistent table where all the nodes were always produced in the same order, and the IDs were gone.
And the theory here is that you would hack a peephole and it changed anything, basically.
Yeah.
And the
those I
cascading
put-
effects would get caught by the naming scheme.
Yeah, I had about 100 fold graph dumps that I made from different graphs in my test suite, and they were committed into my Git repo. And these would occasionally, I'd have a line or two of these break, but mostly they would stay consistent even as I was hacking the peepholes and stuff. So it worked pretty well.
Okay.
It was way better than, for a while, I just had like the raw table committed, and I was spending so much time constantly updating them. But for me, that early on, especially while I was learning how to do the graph, like how to do the sea of nodes stuff, I didn't mind that so much because it would force me to go in and look at like where things were getting affected by when I added a peephole and stuff. But in the end, it was annoying, and I wrote some like Emacs scripts that would like automatically rerun the tests and update the stuff. It was too much. So then I just created this, and 95% solved the problem.
I'm at the place in the simple project where we have too many tests that based on node prints, which include the magic golden number. So they're all golden ID numbers. So every time you change a peephole, all the numbers change, all the tests break, but only on the numbering. It's like, oh, come on.
Yeah, I had a bunch of
better
that
way here.
So far, I don't have any of that in this one. I've got this very simple representation where it's not very useful. I don't know.
Right. So, and we're looking for a better answer there. I do like the bijection concept with the IR dump, and then inject right back into the peepholes with this graph. Even if if I can biject back in, I can probably hand hack that graph and biject it back in.
You know what? Here's something I did also that worked really well. I have some tests where I have like a text version, like a Python string, because this is what my source is, of what I want the result to be, and then another Python string of the program that I want to convert to that result.
Mm-hmm.
And the test, I just give the test function those two strings, and then it compiles both of them, and they should be the same.
Right.
And that actually works pretty well.
Right. I think most of the simple tests are in that category. I give you a simple program, and I give you the output, which is basically a graph walk printed IR. That's my output. And I want to know that this gets you to that. And peephole number changes. Like I have to come up with a way to print a graph IR where I can renumber under the hood and not have it be ambiguous and not have it be so tied on numbers. I know in AA I went ahead and did that. I fixed the node numbering thing so I could get precision things, but I had to do renumbering games or
So for numbering, do you mean just naming the nodes?
Yeah, in this case, naming is like the dumps that Simple are using for tests essentially name the nodes. And the node names include a number. And you want to have, like I have an add, and it's used by 3 different places in the graph. It's a DAG, the add is shared. I have several adds. I want to know that each add is consistently renumbered so that it remains the same across any number of other peepholes that have come through and reshuffle things around. And that's not in there. And so a lot of the tests are fragile because of that. So like last week when I was working on Simple, I added a thing that said, if you see an if x equals y, then inside the if statement, know that x is equal to y by just replacement. And when you come out of the if, you have to go back to the original x. And what happens is after some amount of shuffling, I would get a dependent cast that says I have to be guarded to know that x is y here. And then I have this guarded value, which is basically a cast, and I'm just going to merge it back to x. And so I had a phi with a cast instead of using x post the merge, whatever. So it didn't, the peephole wasn't working well. And the effect was all the graphs looked a little differently, but they were semantically equivalent, but they were not as clean as they used to be. And now, is this what I want to have? What do you want to do with this particular peephole? So I backed that peephole out. But if I run through and do other things, you know, X plus Y becomes Y plus X. The graph gets visited in slightly different orders. Things aren't looking perfectly identical, but they're semantically equivalent. Can I make a test that acknowledges the semantic equivalence? There's, you know, there's something stupid to be done there. Renumber all the numbers low, and as Darrick was saying, hey, make all your ads start at 0, all your subs start at 0, so it's 0, 1, 2, and then probably all your ads are uniquely numbered correctly. Maybe you do renumbering based on data inputs, if you've got data inputs up to a few layers being uniqueified that way, and you can come up with a unique numbering pretty quick. And that might fix the whole, I keep seeing different numbers in my outputs for no good reason.
Yeah. So that one, here's an example of one of the tests that I'm doing this way. I put it in the Google Doc.
Yeah, hang on. Oh yeah, put it in Google Docs. I'm hitting the share button for you, but yeah, put it in the Google Doc.
Yeah, it's in the Google Doc. So
then I'm going to share the Google Doc.
Oh yeah. So it's my test function is just called OK, as in this should be okay.
Yeah, right.
And,
right.
And so basically I say this string is the expected, should,
right.
If I compile that string, it should be exactly equivalent to compiling that string.
Okay. Right. Right. Yeah, the stuff I have for simple is very simple. It's very similar. I'll throw an example in the Google Docs below. Maybe it makes sense to compare. I don't know.
Sure.
Let me find some non-fuzzer crappy thing.
Yeah, so internally to this, I'm not doing any, I'm doing quite a simple comparison here where I'm just saying, actually it's sort of bijection like, because I turn them into S expressions, and I just have a little very simple function that builds an S expression, and if it finds a loop, it just puts a ... in that place. So it's not like perfect, but anyway, the S expressions of these should come out the same. So it is like almost a bijection, but it isn't, because it wouldn't actually fully load. But it's good enough.
Yeah, no, it looks actually, I mean, I'm in the land of Java here, but yours looks very clean. Now, why can't I not select over here? Hello, hello now, how about now? Huh. Code blocks, oh, there it goes. Basically, here's a string. Here's a string. And, you know, in the middle, it just, the extra trues in here I could get rid of. These say print more things out.
Yeah.
One of them prints a graph, one of them prints a ASCII dump.
Yeah, right. Yeah, so you could really change this to be a function that took two strings and did exactly the same thing.
Yeah, yeah, yeah. This is a, you know, it grew up this way, but
yeah,
but it's getting, we have hundreds of these now. Not hundreds, we have 136 or something. We have over 100. It could be done this way. Now it's string and string and walk away.
Yeah.
And then let me show you one where you get the ugly renaming here. Is this a better one? Some of these have really ugly renamings. These are slightly, oh, here's a better, bigger, better test case. The one down here. Exactly. How about now? No, didn't copy.
How do you paste formatting?
I'm not getting my copy into the thing here. You have to cut and paste with a color coded or rich text or whatever. I did this with code blocks on the right. I was trying to paste into the code blocks. I'm just highlighting it. I'm hitting Control C to need it. I'm going to hit format. See if he comes through. Yeah, he did it. Okay. You're supposed to be able to dump code in the block on the right.
Oh, well.
So here is, you know, loop number 12, region 33, kind of like yuck.
Yeah.
The fees got a name that was somehow related. So let me get rid of show graph. So I got rid of the node number on fees where I could tell I had a magical name involved. Because it's a return of ret, and ret is defined as a fee because I have a while loop in the middle there. So that one didn't need
how often do you think you'd get falsely passing tests if you just threw out the numbers?
Probably not very often. The number printout really is the toString because it's the debugger help. And in the debugger, you want the numbers.
Right, but you could have like a two.
Yeah, I need a two test string or something. Yes.
Yeah.
Yeah, and then it would delete that. I think that would make a big deal. And this last time I was hacking simple, I probably fixed these numbers more than half a dozen, less than a dozen, like 10 times. I went through 10 tests, 15 tests, and renumbered them. Because I'm getting really close. I just need a few tests fixed, and I'll pass. Oh no, something else was wrong. I go back, I change. I ignore the broken tests a while. Oh, I'm close. Fix all the tests. Oh, it's almost right. Fix the last one. No, it's not right. Go back, do it again.
I really hate being in the ignoring broken tests mode and then later discovering that I was falsely ignoring a broken test.
Exactly. So I would be willing to ignore a broken test for a little while because they're stupidly for the node numberings. And then a little bit, then I get close to the end and like, oh, don't ignore the test, fix it. Oh, look, the test was actually screaming real. Yes, exactly. Oh, it sucked. Fine. I think you're correct. We could make this test reasonably ignore node numbers on a printout and get away with it. Mostly, we have very few false positives. All right. How to debug your compiler. That's what today's topic has been. Yeah, it's a good one. It's a lot of us are spending our life doing one of those for the other, except for Levo, who gave up on his compiler to do an IDE. Joined the dark side. Oh, he's out. Fine. All right. What else?
Yeah, I was like on the other side of the house. I did what?
You joined the dark side. No, I said you quit working on your compiler to go work on your IDE.
Yeah, I can't stand debugging with VS Code anymore, and got Windows support this week.
Windows and Java, and I'll give it a try.
Yeah. I don't know how hard Java is going to be, but if it's as easy as go and code LLDB, then it should probably be fine.
I have no idea. I honestly, this is not a thing I have done, so I don't know. I have fought with Emacs and Java with bad versions of DAP, whatever, Debugger Access Protocol. And then I gave it up for a while, and I'll probably get back to it some future date. Theodore, you just need to go to bed.
Feature creep is getting me really bad with this IDE. It should have just been the debugger. I shouldn't have not have did DAP and like all that extra stuff because I had GDB like how long ago?
Yeah, you had it right. Yeah.
I did have a topic change if you guys are done with the current
fire
one.
away.
I'm just gonna link it in the chat because I don't have Google Docs open.
Put it in the doc, so keep them. Yes, micro ops.
Have any of you been on UOps info, like that website?
No, but I've seen this kind of stuff before.
Cliff, if you want to share your screen, I had a quick question about just about ports.
I'm not necessarily going to know on the latest and greatest.
So what I noticed was if you see, you can see that there's 4 ports being used on ADC, like the 5th line down.
Fine. A lot of ADCs. So you get something like here. Port. I guess those are ports. I don't know.
Yeah, so it's 4 different ports, but the operation it's 4 UOPs that run on whatever ports.
5 things being summed and 4 sum ops. And P is a port, I take it, and then there's ports like 0156B.
Yeah.
Is that a port?
So Mike, if you look at like the very first ADC, you can see it says P0 and 6.
Yeah.
That means the add operation can be on ports either 0 or 6. But
Or 6,
what I noticed,
not 0 through 6.
no, just 0 or 6.
Okay.
What I noticed was if you store, it's 2 UOPs, but this is doing an ADC on a memory address, and that's 4 operations. And I couldn't tell what the 4 operations were.
Is it generic memory op?
Yeah, I figured I figured that it would be a load, an add, and then a store. But what's the other 1 or 2 that's there?
The
It says
addressing
either
mode
4 or
is
5.
the addressing mode is base plus offset as a constant plus register scaled. So you're
Well, I
putting
think
in 2 register numbers and an offset from the iCache stream and a scale factor from the iCache stream.
this isn't an assembly. I think it's saying that one operation is using a port. I mean, using the first port, then the next UOP is using either port 06, and then the next one is doing 2 or 3, and so on.
What is the question?
Go for it. I have no
why-
idea how to read this, by the way. I'm totally yes, but go, Matt.
My question was, what's with like the because I can understand what 3 of the ports would do. I just don't understand what the 4th or 5th would be doing.
Can you open the wiki chip diagram in the tab for this micro architecture? Maybe shouldn't start with Alder Lake.
If you throw a link in either Google Docs or
Just Google for wiki chip and then go to the next.
I have a link in the chat already.
Yeah, open wiki chip Skylake, for example.
Yeah, I have to now get to chat, which is buried under things.
Just type wiki chip Skylake. It should be first result.
Zoom. Let me find. Where did chat go? Okay. All right. I'll do wiki. How to say wiki? What?
Chip, as in microprocessor chip.
Oh, wiki.
Oh, you already have this in the history, actually.
This?
Yeah, and maybe server. Go to server. And scroll down until you see microarchitecture diagram. It's gonna be prominent. Keep scrolling, keep scrolling. Oh, there we go. You see those ports over here? You have port 0, port 1.
I hear you say ports. There's many things to look at.
6. These are the rectangular things on those diagrams that are labeled port number. Port 0, port 1. If you move your mouse cursor just a little bit lower, below the
It's
scheduler,
the orange blocks.
Below the
down here.
No. These are execution units.
Oh, here port.
The port.
Yeah. Okay.
The port connects the scheduler to the execution unit, and you can have multiple execution units under one port. So you can see there is a whole bunch of stuff under port 5, infamously, because oftentimes on Skylake you would find yourself bottlenecked on port 5. And you can see that port 7 is address generation unit, for example.
Oh, AGU.
You can see that you go to port 4 if you need to store data, because that's connected to the store buffer. So when you need something that, for example, needs to compute address generation and then store, you probably would use something like port 4 and port 7.
How about,
so that's the decoder.
You have a load modify store.
You have 2 load ports, port 2 and port 3, in contrast to having only 1 store port.
See, the thing is, if I do a load, like a memory load, it's only 2 UOPs. So there's no address generation unit being used there. So it's just weird seeing how many UOPs loading versus modifying.
Can you go back to the micro ops?
Yeah, let's say as soon as you do an address.
And maybe select Skylake X, as in Skylake Xeon, because that's gonna be exactly the diagram we have just seen.
Yeah, let me find Skylake. Skylake X?
Yeah. And the ports you see here, they should correspond exactly to the ports we have seen in that diagram. So you can see that 3 micro-ops will, for what you highlighted, 3 micro-ops will be dispatched to either one of port 0156. And in addition, one will be dispatched to either one of ports 2 or 3, and in addition will be dispatched to either ports 237, and then one will be dispatched to port 4.
Right.
You probably also want to deselect the Alder Lake.
Yeah, yeah. I'm figuring this whole thing out. I didn't figure out what it was until like how that was all put together. Well, that didn't help a whole lot here.
See, I still don't know why the store requires the address generation units, but the load does not. And
The load
I
has
don't
an
know what
address
the
generation.
third op does.
No. Come over here. Port 2 and 3, they do an address AGU, address generation, and a load.
Yeah, you just have the AGU under that port.
Yeah. There are like 3 address generation units. Then there's 1 and 2, 3, and port 7. And 2 and 3 couple address with a load.
Also, if you click on the name of the op, it brings up a more detailed page. Like if you click on the entry in the base column, whichever one.
Okay, yeah. I'm looking at a good one to pick up here, like add with memory and register as opposed to add with memory and 0.
Yeah, so then, and you scroll down, it actually has like an explanation of the port usage in some places. Well,
throughput measured, number of UOPs, 6. 4, if you have an indexed addressing mode, you have an extra UOP.
What if you click on port usage?
Where do you see port usage here?
Yeah.
Okay.
Oh yeah, I think I know what he did. It's what you get from perf, because you can run micro benchmark with this assembly code, and then you can use perf to measure the port utilization, and you can see that for all of those 10 cycles, we were using port 0 also for full 10 cycles here, because you can see instructions with 11 core cycles, 10 microops port 0, 10. So these are directly measurements from Linux perf. And you have 10 commands. That kind of made sense. So when you will begin to see multiple ports, this is probably when we will see this dispatching that can go to either one of those.
See, I hate reading this page because it's so weird to me. At the beginning, it says there's 3 operations, but it still says like there's 5 ports. Like at the
on this page here or the prior page? Which page are you talking about?
Well, I'll just look for it on what you're looking at.
Yeah.
Okay, so
right now, right?
I saw it in a different page, but I don't see the information here. So this is not telling me how many operations it's happening.
Oh, here, number of UOPs, 6.
Yeah, so it's not listing each of the 6. So it's just really confusing. Like I can see it says it lists the ports, but I don't know what the actual operations is. Like I think I saw one of them use address generation unit twice, and it's just weird. I was hoping someone knew off the top of their head, but maybe this is just very CPU.
So this guy runs add with carry quad word R14 R8 a bajillion times, and he says, "Oh look, I've used port 0 and port 1 some fraction, and then you can hardware can pick between the 2, and I usually end up picking a port 5 or port 7 or whatever." Is that what you're?
I think this is just like explaining how they figure out that specific instruction took like that many UOPs.
Yeah.
Like I think this is just for you to check their work. This is like it's not that helpful to me.
Oh, okay. Oh, okay. I claim he's doing something like there's an AGU load for a micro op. There's a store for micro op.
It's very easy to see how it sits. Just look at the port usage. Yeah. First, you have 1 micro op that goes to one of those 4 ports. Then you have 2 micro ops that go to those ports. Then you have 1 more. 1 plus 2 plus 1 plus 1 plus 1 equals 6.
Right, and you get 1 more. You get the extra 1 if you're indexed.
Yeah, and if you look at like right above, it says latencies. You see it says latency operation 1, 2, and 3, not 6. So it's just weird.
I'm sorry.
What?
Where are you looking at?
At the very top, where it says Skylake X, it says measurements, then latencies, and then you see latency. 1, 2, and 3, or latencies.
Yeah, more or less latency according to whether your operand is address
so
as
it
a
says
base.
3. Yeah, 3 versus 6 UOP. So it's just weird to me. Like I just don't understand this page.
Oh, but it's like if you're doing register to register.
These are not microbes. These are just cycles.
These are cycles. Yeah, that's correct. Yes, right, cycles.
Yes.
Right. Because you're going to go to memory here on Mr. number 11 cycles, but that's going to be assuming an L1 cache hit. You're still going to get like 3 or 4 to get to L1 and back, plus the actual math. Whereas the register to register guy is like, you know, we're down here 2, something like that. So that's latency. This is porch. I think the porch totally makes sense to me. I'm understanding what Matt's saying there. It completely makes sense.
Yeah, so
Coffee Lake, yeah.
The other week when I was talking about LLVM MCA, machine code analysis, they talk about ports, and then I end up looking at this page. But I understand enough of it to write the code. I just don't understand the details.
What were you trying to accomplish using that information?
Oh, I was just wondering what the details meant. I like.
Okay.
Yeah.
Like when I was doing the billion row challenge, the parsing of the innermost loop got into people doing software as a register or whatever, you know, the register as a SWAR, what the hell thing is, software pipelining. And then you started to care like details of who touched which ports and what, because that was all your time was the actual act of parsing. And other than that, like almost never do I care at that level of detail. It's the compiler's job to go sort out.
Sometimes on SIMD you will care because, again, you may be bottlenecked by this one particular port, like port 5 for Xeon. And then it's actually sometimes better to use worse instructions that seem like they would have longer latency, but just because this instruction sequence may use other ports while your port 5 is busy, this may pay off.
Right.
I'm almost convinced that you can't, like, your code can't be fast enough to beat the prefetcher on the hardware until you start using multiple threads. Then you're always memory bandwidth limited.
No, certainly in the billion row challenge, it was routinely the case that you kept hacking the expression of how you walked through to parse, and you kept getting faster. So you were bottlenecked on something. Oh, you're saying not the parser. Yeah, you were not a prefetcher. You were not bottlenecked on the prefetcher. Yeah, okay. Yeah. The data was available if you could work your way through it faster. Did I catch what you're trying to say there, right?
With my compiler, when I use multiple threads, basically my code was fast enough because it's just waiting on a memory bandwidth. But when I do tests with just single threaded, it seems like I'm never memory bandwidth and optimizing will make a difference.
Go run the billion challenge using Bolin.
Yeah, I wish. I need a hash table.
Well, no, do the single threaded version. It's actually really simple. It's open a CSV file and parse, and then figure out if you're bandwidth bound on one thread or it requires 2 or 3. Like
the thing is, my compiler knows if I'm doing something suspicious with my code. So when I write a hash table, since it's not actually implementing like pointers safely, it knows I'm doing something weird and it will give me an assert. So I have to hack my compiler in order to do that.
I think your compiler is a little
I might
too
as well do
aggressive
memory safety at that point.
of what it says is safe or not, because hash tables are a big deal. Hash tables need to work.
But doesn't Bolin use like a non-optimizing compiler in favor of compilation speed anyway?
No, he could go both ways. He hands it to TCC or hands it to LLVM or Clang.
Oh, okay.
Yeah, I have multiple backends, but the issue is just implementing the hash map because my compiler knows if I'm doing something weird with pointers.
But he has a
so
very
I have to disable all the certs and
memory
even then
lifetime.
It might not work.
Yeah. And need to sort on hash bits. All right. Anything else? Something else? We can be done. We're early today. Not early. We're short today. We had a bunch of regulars who were out. Darrick, you're muted.
Earlier, you were mentioning an update on XTC.
Oh yeah, I'm going back and forth whether I'm doing XTC simple or A. I have too many projects co-running, and I split my time between them. Fine. Yeah, I don't know what you do. What I was going to say there. Nothing important. That's for sure. I had to go restructure. So I'm reading in an AST that's got way more complexities or one-offs than it should ever need. And I have to, every time there's a one-off somewhere, I have to go figure it out and one-off the Java version. So I'm rewriting, and I ended up rewriting the rewriter or most of the rewriting passes. So I went from walk it once and build an internal data structure in Java that looks like an AST. Then, and in that pass, I was trying to put typings, and the typings are a blended type that understands XTC types and Java types and primitives, Java primitives, all at the same time, and I can move between them. So there's some things in XTC go one-to-one to some Java type, and some things do not, and some Java types have no representation in XTC, and so on. So the first pass was parse and build types, and then the second one was just rewrite the graph, and the third was to pretty print it as Java code. And then I needed a pre and a post rewriter, so that got more complicated, and then the typings got more complicated, they got their own pass. Then the pre-post rewriting wasn't actually doing it yet again, and it had phase ordering issues in it. And then I had a lot of things where I wanted to promote an XTC integer, which a naive presentation would only ever be a heavy wrapped integer that had a lot of extra virtual call functionality thrown on it, like you get out of like Python or something, JavaScript. And then the unwrapping of that when it wouldn't work wasn't always correct. Anyhow, I had to go rewrite them all. So now I have a pass to parse, and it doesn't have anything with types, a pass to type, and it seems to be pretty stable, a pass to unbox everything I can, a pass to rewrite all the complicated things that don't have a Java presentation directly into a Java style where I have unwrapped everything where I can, and then a reboxing pass, which I've now been debugging for the last half a week, which looks at things where I just have to give it up and go back to being a boxed version. And then the Java pretty printer is also pretty stable. So that was all week, was rewriting the rewrite passes and getting myself back to stable and finding all the test cases where I couldn't do whatever. It was very non-trivial. Even the reboxing is itself just very non-trivial for no good reason.
Never realized, because I only ever dealt with closure numerics, and they're pretty nicely designed, but I never realized how annoying boxed numbers are in Java until I had to deal with them.
When I say boxing, I am not using Java's boxed numbers.
Oh, okay.
I'm using my hand-rolled versions that don't do any auto-boxing. Auto-boxing sucks. So, but I'm all generating the Java code directly, so there's no auto-boxing. I'm just going to put out what I put out. But I need versions that have all kinds of extra virtual calls on them that have nothing to do with anything to Java.
Yeah, I've been slowly writing out everywhere that I used auto-boxing, because it just ends up being, I don't know what it did, and then it's
auto-boxing is not a great idea. Having stared at it, I don't know, there may be a handful of use cases that it works pretty well on, but 3 times in the last, say, 3 or 4 years, when I took a consulting gig to go help somebody speed their code up, the first step was get rid of auto-boxing. And oh gosh, that was all of it for 2 out of the 3. I was just done. It's like, oh, come on, what the hell? Let's see, what's for problem here? Oh, your problem is your infinite GC. God, you're spewing GC. Can we raise the heat? What's the GC look like? Oh, it's infinite Younggen. Oh, you're out of bandwidth. Oh, you're over allocating. What are you allocating? Well, one of them was bazillion strings. So we interned them all, problem went away. And the other one was, oh, a billion longs or ints or whatever. Oh, we'll quit doing that. Jeez. Oh, look, we got 40% faster in like 2 out of 3 cases. And the other one was SLA based, and he went to 95% to 99.9% SLA after getting rid of the extra, whatever. And it was just like, okay, fine.
Wow. Isn't string interning like a kind of...
Yeah, it wasn't, the fix wasn't called .intern. The fix was get them interned and use them under the interned name. So you didn't allocate a string and then replace it with the interned one. You couldn't allocate. So there's no allocation. The rule is no allocation.
Yeah. Okay.
So most of them was he was using God, where he pulled the names out from somewhere that turned into I allocated them, and he really just wanted an enum. And so you make a public global static string equals quote, or you just use quoted strings of identical nature, but he wanted a named version. But if you use quoted strings, you're okay, because that's interned by the compiler. And it cut his string generation by 90% in a few hacks. And then I helped him sort out the remaining few. And then suddenly his allocation rate dropped hugely, and his SLA was suddenly hit all the time. And he was a happy camper, walked away.
That's actually really surprising.
It's a common pattern in Java for people who are not very performance aware. What is the cost of allocation in a garbage collector language? Well, everyone knows it's a bump pointer allocation, right? It's 1 clock. Plus, it's a hard, guaranteed cache miss because you're only allocating memory that has never been seen by your CPU caches since the last full GC cycle, or the last young gen cycle. And that means you get a hard cache miss. And that means the cost is 300 clocks times 4 ops you didn't, or 2 ops you didn't emit. It's pretty hefty. So don't allocate. Now you're writing Java code. Joke? I'm sorry?
Wow, that's like a big latency. What was that joke that you guys had about writing C++ into Java, then Java to C++? What was the ratio?
I don't know. I don't know what this
was. It 3 times slower or 2 times slower? I can never remember.
If you took any of these languages and wrote them something else, and then took a naive translation from the something else back, you would just, you just lose each go around by large integer factors. Sure.
It's like like putting a text back and forth through a translator.
Right. Yeah. Take some nice Shakespeare, translate it to Chinese, translate it to Japanese, translate it to German, translate it to Portuguese, translate it to English. What's it going to look like? Nothing like what you started from. Going to be so bad. I've done that with some stupid thing before. Somebody gave me a bad English translation of something, and I went, well, let's go back to the original, and then back again. And you go, ha, 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 ha. You look at it, it gets worse and worse each go around.
See, I was kind of wondering that if someone was writing Java and was specifically trying not to allocate versus like people who write C code who does not try to optimize and just writes it like their typical C++.
Yeah.
Which would be faster? Because I kind of feel like the Java might actually be faster.
Yeah, there's a trick question. So if you get your product to market faster because the code was easier to write, it's generally more profitable overall than getting it to run fast as one of the features that you have to get many features to work. So unless you're selling speed as the main thing, you actually want to get it to market, then come back and go faster. So now that it's working, you can do big O translations, and big O improvements will trump all other things. So you win giant speed ups there. Once those are done, and now you're looking at why is my Java slower or faster than the equivalent C code, maybe its allocation is the issue. Now,
because the Discord, we were talking about reference counting, and it made me think about allocations. And I was like wondering, does the typical C++ code, like the average C++ developer, do they allocate a lot more than they think? And then Java, because you don't have to make as many copies, you can just pass pointers everywhere. It's like less data.
No,
like I don't know how the typical people write their C++.
And when I was writing it, and when I looked at other people's writing it, they paid attention to when they allocated. They tried hard not to. If they had phase-oriented problems, they went to arenas. People talked about using reference counting. It was used rarely. And no one would ever touch DC with a 10-foot pole.
See, the last few people I worked with, they never did any of that. They just wrote code.
Okay. And then when you got to Java and you didn't have to care about lifetime, people quickly, not instantly, but over the course of 10 years or so, the set of programmers who would have been C++ programmers that moved to Java quit worrying about allocation. They were much faster to build applications, much quicker to get things functional and running, much bigger, interesting applications got written because you haven't put all those brain cells on fixing your allocation bugs, your crashes. Okay, and then you get to the GC limits, and then suddenly GC is your bottleneck, and the complaint goes back around to GC, you're not the GC. Oh, you're stupid because you're using Java for GC. Oh, you're stupid for having to sweat malloc-free, whatever, the flame workers on. But you could go back to your Java code, and I say not allocate. What I mean is, statistically speaking, you're not allocating. Of course, you allocate all over the place, and you don't have to track it carefully. You don't have to be super concerned. You want to be statistically not allocating. So if I go to that billion row challenge, if I were to allocate for every byte or a ratio percentage for every byte that passed through the system, that's a clear loser. And no C program would ever write code that way. But the naive Java versions all start that way. And then you realize you can't do that. So you just drown in allocation. So you statistically don't allocate. But hey, there's 10,000 unique cities in the data set out of a billion rows. So you're going to have at least 10,000 allocations, one for every city, and 10,000 tiny objects in the hash table and 10,000 little this and that's. But 10,000 is tiny compared to a billion, and you don't care. So statistically, you're not allocating. It does, you can write fast code in Java, but you can also be a lot more careless about things and let minor allocation things slide by without having to stare at them. That's sort of where, when I got called in on those projects, that was where they had gone. Hey, I got something working. It worked well. It was big. It was fancy, but it was got performance issues now because it got popular too. And then what do we do about it? And then, okay, well, sort out where the time went. The last 3 times, allocation. CPU is way faster than memory. So. All right, I think I'm preaching to the choir. I should stop.
In C, also, I think one of the ways you have in allocation is that an ecosystem of good C libraries will accept buffers. It will accept pointers to pre-allocated data. So you can use C libraries from third parties and be almost sure they will not allocate behind your back. But it's relatively rare, I think, in Java or C# to be able to count on the entire ecosystem of libraries to not allocate behind your back.
No.
And accept to just give behanded buffers.
Yeah, they're just, yeah. And you say not allocate, like I kind of don't care if they statistically do not allocate. They only allocate a small fraction, some startup code, time, whatever. But they could just allocate a lot. And in fact, in Java, it's common that they will. Fine. Yeah, there's a performance thing there where you'd like to say, here's an easy to use library, and then here's a version that can be used in bulk, but it's a trickier API, but it'll run faster if you're going to use it a billion times. And they're different APIs.
Yeah. Anyway, if you really need to use a third-party library and someone wrote, the Java one or whatever that you want to use is not great, but there's a C one that's really great. Like, can't you just use that anyway?
Well, then you have to go to JNI and
yeah.
pain in the butt.
Isn't that being improved?
Whatever. I just suck the jar file and import, and I run. And I have an API, and it goes.
I think this is something that bothers me sometimes about like very core like libraries like memset, memcopy, which end up taking a lot of time in many programs.
Right.
But like there's always this dispatching logic inside of it. And, it would be, I think, nice if standard libraries actually provide ways to like or allow you to specify directly, maybe at compile time in a nice way. Like, okay, for instance, like it's very common in some certain types of kernel code to copy pages. And sometimes you want to copy small strings, and sometimes you want to copy gigs of memory. So like they're so different, and I think not being able to specify them nicely is like everyone wrote their own memcopy so often in all kinds of languages, in all kinds of like libraries, kernels, everything. Like, yeah. I don't know how often I've seen a new re-implementation of memcopy for a particular buffer size. It's like already a meme.
Right. There is a mem copy, and then there's, oh, look, I know I'm copying pointers. It's 8 by the line. Skip all the alignment crap. Oh, look, I'm copying pages. Oh, look, I'm copying this, that. There's, yeah. Yep. You just call memset or memcopy every time, and it has to sort. I guess the compiler could probably do a bunch of optimization to know something, and maybe C2 certainly took a bunch of work to know something about what it was copying and skip some of the leading dispatch logic. But it was.
I'm a little surprised that no other languages tried to do automatic memory with no collection, like no
plenty
garbage.
have tried. You just,
yeah, because I never heard of them.
I'm sorry, Python, Java.
No. Automatic memory memory managements, but without collections.
Like Rust.
You still got to specify where things allocate and.
What do you mean by that? So automatic memory management means almost surely implies collection. So
yeah, it's collect. Somebody's doing the collecting. So you say no collection, but then no one everyone.
Okay. I think someone once showed me a language. I don't remember, it was like Cyclone or something else, but something kind of tried to do it, but I wasn't sure if they were doing what I was trying to do.
There is a the Cyclone has something called a semi automatically. So it has a region, but it's akin to Arena and goes away when it's almost it's the same thing as Arena. So.
Like every PHP program wipes out its memory for every screen or every page loaded. It has a basically an arena that's done on a page request boundary. And okay, so these are all collections. Like your program collects as you write and you return. You go down into a function call. You allocate stack space. You unwind from the stack. You've collected. That's a collection, right?
Because of what Adrian said just reminded me that I really want to finish my language, but that's going to be a long time. But one of the things I do is there's no new keyword, so you just say I want to use you want to assign this string or this variable or whatever, and the compiler will.
I'm going to count primes to 1,000,000. I want to make an array for my sieve of vertices. How do I do it?
That's one of the few times it will allocate, but it's the compiler chooses it. You don't say there's no new keyword.
Right.
You could say reserve this amount of much data if you have an idea of how much data you need.
How do I make a thing in Boolean that effectively is an array of ints 1,000,000 long, and I'm going to collect my primes in it?
Well, okay, so usually built-ins are the things that allocate memory. So with ints, if it's a fixed length, it will just do a static
well,
array.
The usual one is I read from the command line how many primes. So I get an in. I do a read of an integer from the command line. I get an in. Now I want to make an array of size n.
So you would use a dynamic array, and since that's a built-in, it understands how to allocate.
So I said that's a new. That's your flavor.
Yeah. So you can do that with built-ins, but you can't really say I guess it's just really weird trying to explain it, but the idea is the compiler will pass in references and pointers and all that, and if it can align an allocation, it will do that, because your library could just be pumping out could generate tons of strings, but if the parent knows that it's destroying it each time, it just passes in a pointer, and then the library just
There's plenty of languages that do that at a compiler optimization. Anyone who's doing any sort of reference counting, say Swift, will have that the reference counting will show up in the compiler and say, oh, you make it, you throw it, you make it, you throw it.
There's also this weird thing that Go does. I don't know how many are familiar, but if you return value from a function in Go, it may be stack allocated or it may be heap allocated, and it kind of tries to track this using escape analysis, whether it's going to need to allocate on the heap or on the stack, because maybe you're just calling a leaf function from somewhere, or maybe you're just passing this everywhere all over the code. So coming from C++, to me, it's kind of weird that the return value from a function may or may not be allocated on the heap or on the stack.
Oh, the stack. Yeah, that is a little weird, yeah. But he said go ahead to GC to clean those up.
I'm kind of trying to do what Go did. Like, you don't know if it's in the stack or the heap, but I haven't had all the details like set. It's just I have enough working that I know the rest is not going to be too difficult.
I'm still waiting for hash tables to come out. You go run the billion row challenge or the cliff click 100 million row challenge. You know,
I'm waiting for a good C++ debugger.
All right. Well, you're stuck behind getting your IDE going just fine. Like I said, I'll play with it if you get it going. I'll play with it. Got Java.
If you give me feedback like every week, I'll try to implement something every week, but no promises on what I'll actually implement.
You know, it's fine. I'll play. I'm sure it'll have something missing. That's fine. I'll tell you, and then I'll go back to what I'm doing so I can make progress. And
right now, I thought all I would care about is having a find, like to search in a file. But it turns out I use like a global search a lot. So I'm not going to do that right now. I want to finish the DApp.
Okay.
And then and see if I can get Java, and then I'll worry about that afterwards.
So in Emacs, do I searching? If it's in a file, it's Control S for the incremental instant search, and if it's cross file,
I bet you use that all the time. So I don't know what I'm using all the time, and when I try to use my IDE, I just notice what's missing like immediately.
Yeah,
like I can use it probably for like a half an hour.
And your code style and mine will be different. You know, we'll have different things that I'll use all the time you won't, and you'll use all the time and I won't. Yeah, that's pretty normal.
Yeah.
All right, I'm going to call it anyhow. It's time.
I had maybe one thing, or do you think?
Yeah, go. Yeah.
I made some progress with my register allocator. Basically, I'll keep it short, but so like I have some constraints that make some things simpler in my like IR design. I went back to having an IR this time, and so yeah, it's a very low level IR just for register allocation, and so I have some constraints. Like for instance, I only allocate or I only consider like I only allocate registers for blocks that are at least at least have 65k instructions. So I have 16-bit indices, and I also have at most 65k virtual registers, and also for each virtual register I can have at least at most 65k live ranges. So that allows me to basically, I could for instance pre-allocate a massive array. And like I can share my screen. Actually, it's like a bit visual.
Yeah,
should be quite simple.
Visual's good. You should be enabled. You should be able to share.
All right.
But 65,000 C2 went with that for several years before we bumped it to handle even larger, but n squared catches up to you, and so we didn't want to do much larger. I claim.
Do you see my screen?
Good read. Yeah.
Right, I think it's 65k. Okay, so basically, I was thinking of it like a matrix of like the first index refers to the virtual register, and the second index the live range index. And of course, this matrix won't be actually filled everywhere with values. I mean, one virtual register might have only one live range, but some registers might have multiple. And the question is, how do I lay out this thing in actual memory? So one thing I could do, which would be probably stupid, like I noticed was quite slow, is for instance to give every virtual register its own dynamically allocated vector. And then I need to create, well, dynamic allocations for each of these rows, which was too slow for my use case. Right. One thing I could do, which would be the simplest, is to have everything in a big array and then index them like this. So I just go from 0 to 1, 2, 3, 4, n-1. So
you're doing a graph coloring register allocator.
What? No, I'm doing linear scanning.
I'm a little confused. I did, you know, several graph coloring register allocators.
This is linear scanning.
Had live ranges and their interferences with other live ranges. When I built the interference graphs, I want to say I did a bit vector one way and I did adjacency matrix the other way. But the adjacency, the time I had a 2D thing, it was indexed by live range on one dimension and list of live range, an array of live ranges in the other dimension. But the virtual register numbers never pointed to any live
Yeah, well,
ranges.
this
Not a set
linear
of live
scan.
ranges.
I'm doing a linear scan. No.
Oh, you're doing
graph
linear
coloring.
scan. I'm
Yes.
sorry.
Yeah, it's all about like time constraints in my case.
You're adding, so within a basic block, you're adding live ranges and okay.
Right, yes. And so the thing is, I decided to have like basically one large allocation, and now I need to decide how to index it, because I want phases of continuity or like locality, because during the linear scan, I sometimes need to iterate through all the live ranges of a particular virtual register, as well as multiple live ranges of multiple virtual registers. Sometimes, for instance, the first live range of multiple, for instance, sometimes I need to go down basically this column. I need to check the first live range of the first virtual registers, like here. So this needs to be quite efficient, and but also in this direction, I need to have some kind of locality.
I didn't build this structure when I was doing linear scans.
Yeah.
So there's going to be no short conversation here because you're diving into a register allocator.
No. I will not talk about the register allocator. Just one thing I noticed, and that is that basically it's just about the choice of like how I want to index this big array. For instance, it's all about tiling basically. So the easiest way would be, for instance, to have the first 65K like possible live ranges of the first virtual register all in the first 65K entries. So I would iterate this matrix like this. So I would start in the first row, then go second row. But there's problems with cache conflicts, and it's just not an efficient like way to
let's say
index
you shouldn't
matrix.
be walking 65,000 live ranges anytime soon.
Exactly.
Linear scan, no matter what.
Right. Yeah. So another way would be, for instance, to like iterate through it like this. So for instance, I look at let's say the first 3 live ranges of the first 3 registers.
Oh, I understand what you're trying to tile here, but like I said, this is not the structure we want to use.
Why not?
Because it's 65K in some dimension. In the linear scan, I only ever had in registers. I only have 16 or 32 in one of the directions.
And right, that's exactly why I'm tiling it. So I don't.
I'm saying I would look at most 32 things per instruction as I'm walking instruction by instruction by instruction. Mm-hmm. Not all possible live ranges as I walk instruction by instruction. I'm just thinking, I don't know where you're headed here with this, but this seems like you've done something that doesn't sound. A speed goal out of linear scan implies you don't want anything n squared, and so you don't want anything that's more than count of registers times count of instructions times some constant. So
well, I was thinking of like the phase where I'm building the intervals. Like it requires me to add live ranges to an array.
Right? So if you're building intervals and you're building live ranges to get an interference graph, you're already into graph coloring, and then just
no, there's no interference graph. But I need to build intervals. Like for every virtual register, I build intervals. So I just collect live ranges.
Yeah, well, all right. I would say an interval is I've got a virtual register here and it ends over there. That's a start and a stop point.
That's a live range, right? An interval is a collection of live ranges that can be separated by lifetime holes.
Okay. Yeah. Well. All right. I think you're heading into graph coloring now. You're calling it linear scan, but it doesn't sound like it.
No, this is like this definition of interval is I mean, that's the literature definition of live interval. And this is actually from the 2008 or 9 paper on optimized like interval splitting. So this is pretty much like, yeah.
Okay.
The thing is like this.
But throw a link in then.
For sure.
Like I said, I've done a bunch of linear scans, bunch of graph colorings. Linear scans never got anything close to n squared anywhere ever. Nothing close to 65K ever. 32 times a list of registers. And did, you know, pretty decent. Could do fine.
Yeah, basically my point was that there's like during interval building, there's dynamic allocation, and the thing is like I have like
ignore what I'm saying because I'm trying. I'm trying to map linear scan to what I think of as a linear scan, but I'm not going to try to do. I don't have in my head anything useful to say about interval building. So I was not understanding linear scan conjoined with interval building here.
Right. Yeah, right. It turned out that like interval building or like all like for instance, collecting use positions, like, this is another thing. So let's say I split an interval, and then I need to, like, after the split point, I need to change all the like future uses of the split register. And I need to like rewrite it, all the later instructions. The ones that used this virtual register that I split, I need to now translate to the, like, rewrite to the, or patch to the new register. And this requires me to know all the use positions of every virtual register. This is another like set of dynamic allocations and stuff. And this is really, really bad. Like if this stuff requires me to do pointer chasing, I'm dead. Like this basically halves my compilation throughput. So basically, I was looking for trade-offs where I can have like moments of spatial locality and like find ways to creatively tile it. And I can have multiple like tiles like this, and then actually combine them into a greater tile. It makes the indexing horribly complicated, but then I can, I don't know, create like larger tiles and iterate through it in a complicated way, but it really like I don't know, outperforms all the other dynamic allocation strategies that I tried out.
Right.
So
I'm still thinking you shouldn't be doing interval building if you're doing linear scan. And then because you are, I don't know what the heck you're doing after that. And then and then you've got performance issues. And I'm like, don't do interval building.
I have
I'll drop a link, by the way, in the
drop a link
of this.
Just a very quick question for you, Adrian.
Yeah.
Why did you choose to do linear scan versus graph coloring?
Because I'm like for me the compilation time is the most important thing right now, or like for the future. And the thing I was trying to like, so I had a first version that was pretty okay, but the code generation quality was pretty bad. And since the Discord and the CCC is full of optimizing compiler enthusiasts, I kind of got dragged into maybe creating something that is more useful. So like I set myself a goal. I want to have at least Clang-01 performance, while still being at least above 5 million lines of code, like compilation throughput. And graph coloring doesn't get me there as far as I can see.
What? That's faster than mine. And I could only do 3, and I thought I was fast, and that's without optimization.
Yeah, well, graph coloring, you know, you gotta just throw multiple cores in, and the problem's solved.
No, with multiple cores, I can do like 60 million or like 100 million lines of code. But you know, like I also with basic inlining as well, so it works quite well. But I have this like bar that I don't want to cross, or like the threshold I don't want to go under. So that's why
I think certainly if I looked hard at C2 under a modern processor, I probably could get you to 1 million lines with graph coloring on, you know, reasonable sized function bodies. But there's definitely a limit in linear scan to definitely be faster by some fraction. So, but I don't know if you're going to interval scan, you're going to get there. That's not. There's plenty of good ways to do good linear scan. I wouldn't start with intervals.
This
So
is
do
just
you
a
have some-
rhetorical question, but what are these giant code bases you guys are compiling? Because I've never noticed the like I've never really cared this much about compiling millions of lines of code per second.
I'm C2. I throw whatever junky Java code you get thrown at me.
I can tell
Million
you,
lines of
C2
code.
isn't millions, and it seems like it's okay, right?
I mean, at work, I'm working on a like 1 million line of code Rust code base, and I'm like regularly smashing my head against the table because I have to wait. So like it's a super big drag on productivity. Like and the thing is, same for the like I have to compile the Linux kernel regularly. Even that is really painful. I mean, I just like yeah, for large code bases like this, it's really really important for me. Like I just need this interactivity. It's just the way I program. So
No, I'm totally with you on that one.
For LLVM, a common bottleneck in building is actually linking stage, because it doesn't always parallelize. So if you just incrementally recompile or rebuild and modify something, I'm often not bottlenecked on compilation time, but I am bottlenecked on the linking time.
yeah, that's another thing. Luckily, I don't link anything.
Are you compiling Rust? Are you trying to get a fast Rust compiler?
Me not, no. I'm just saying like I'm using Rust at work, but my compiler is written in Rust. It is like
Yeah, but your graph coloring, where did that IR come from?
I'm building it myself. It's just very simple.
The input to the IR wasn't you handwriting. The input came because you converted R code or Python to your IR. These are obviously bad choices. COBOL. You're writing COBOL compiler, and you're.
No, I'm writing. I have my own language. Or what do you mean?
You have a language that we haven't seen before.
Wait, of course. Yeah, I'm working on a programming language.
And that's what you're trying to go compile against.
Yes, no, compile against. I mean, I have a programming language, and I'm writing a compiler for it. And
well, someday, not today, you should show us your programming language.
I actually did show a few snippets of like, for instance, inline assembly support. That was quite nice. But yeah, sure. Like, yeah, I'm planning to like. I was hoping to like this year finish like actually a complete prototype of a OS kernel written in my language. I have a few already that can boot on like virtual hardware. But yeah, I want to get some virtual like vertical slices. So I want to like write a complete program.
This is the C1 version of things. This is a later C1 version. I'm looking at your paper.
Yeah, this is like hotspot related, I think.
This is the C1 version. Okay.
Yeah, there's the author has an email address, so you can like attack him for his choice of words.
No. I mean, I worked with this. I worked with these guys a bunch at Sun. Then I went to Azul, and I used the damn C1, and the allocator had a lot of issues, and I couldn't sort it, so I took the defaults, and then it did. It's your trade-off between quality, speed, whatever. When I did linear scans, I certainly didn't do anything with intervals, and I got perfectly good allocations out in really fast, and they're obviously not as good as what you got out of graph coloring.
Yeah, I also talked about Yasser about this. He mentioned. I mean, I was wondering exactly about this. Like, can I skip this? Or the only reason this paper is talking about intervals is because it includes lifetime holes. So I could make my life very, very simple by just ignoring lifetime holes and just using just a simple one range for one virtual register and be done with it. But then Yasser made some good points about how like lacking this information about lifetime holes actually stretches out lifetime sometimes enormously. So yeah, then I got a bit insecure. So I'm just trying to follow this paper like
when the lifetime gets stretched enormously, you just spill the sucker. Now it's a much shorter lifetime.
Right.
Fine. graph coloring and sorry, any register allocator has an infinite number of things you can go work on. And fine, take this paper and go. I certainly know that they didn't build giant graphs for their register allocator, so I don't know what's going on with you and getting some sort of giant graph. It wasn't a memory hungry thing by any means. I'm trying to see, I have to go sign into whatever and pull the paper up. Fine.
I should have, yeah, I can link the actual PDF. Yeah, my bad.
Oh, that'd be nice. It's for client. So the deal with anything behind a paywall is people who come read, want to search the links, they have to go get past the paywall. So if you have a PDF that's legit, then that's fine. I would love to talk more about that next week, not in the last 10 minutes before it's time to be done.
Yes, didn't want to turn this into a big thing. Yeah, so.
No, it's just like there's like a lot of these things you can have a short conversation, but a lot of them, oh, look, there's a can of worms under there. What's this can of worms? What's that can of worms? And pretty soon, boom, well, that's great conversation, but it's not short. So bring it up next time. That would be a great topic. All right. I'm going to call it. Till next time.
See ya.
Bye-bye.
Bye, guys.